All right. Well, now that we've had our AI and electric vehicle lecture, which will be on the final now, unfortunately.
I learned something. I didn't know.
And that all started with my car did a software update my way to school today.
Did you have to pull over? Or
No, I was able to cancel it.
Okay.
But I had to use the app. There was no way for me to cancel it from within the car. Right. And I don't know what would have happened. Like I may have still been able to physically drive the but one interesting thing is like turn signals wouldn't work. All those things happen within the computer. So you can physically hit the turn signal thing, but you won't have a turn signal.
Hold down the window.
Yeah. Doing the bike, what is it? Good excuse. A student's late to class. What happened? Oh, my car rebooted. my car crashed. No, are you okay? Yeah, I think there was a software update. All right. What was the homework? How was the homework easy? See, create a class named dice. A dice object holds a number of sides. A dice object has a roll method that returns a random number between 1 and the number of sides at the instance of dice, blah, 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 blah. Okay, so we're writing a dice object, right?
Method, I tried using like, the .cpp file.
Yeah.
And it wasn't working. I had to do it in the main file.
Okay, well, my theory is you did something wrong.
Yeah.
so let's take a look and hopefully I don't do something wrong. Recommending who?
Like having it with the 2 separate files.
If you want to do it in one file, that's okay. I would still recommend you do it in 2. Not just that, but also the self-documenting aspect of it. And I'll show you that. I'll just tell you what I mean by that. So is this the header file? Yeah, so our number container we wrote last time, it doesn't have that much crap in it. So if you were to have implemented this entire thing in here, it wouldn't have been a big deal. But imagine that you have a major program in industry and your object here does 300 things. It's kind of nice to have this nice little kind of Cliff Notes version of this is all the stuff my object is capable of doing. And then in another file, you actually have the implementation of that stuff. So even though in this case, there isn't a significant difference in size, in real life, there might be thousands of lines of difference is the reality. So I tend to like header files just from the perspective of a self-documenting. Java doesn't give you the option. Java, you would put all of it inside of a single file. Yeah, so Java, you don't have the option to have a header file and then an implemented version of that. It's all one file. I'm just renaming this to HPP, which is the naming convention for C++, but it doesn't matter. You can name it .lol, and I think as long as that's what you include at the top, it'd be just fine. Just header files are a known thing. Yeah, so to your point, you could probably make a pretty reasonable argument why having it all in one file makes more sense just from not just this, but I mean, even what I said is like, oh, it's nice to have the self-documenting thing. You could also say, well, in a large project, do I want 600 files or I want 300 files? See what I'm saying? So you could have a trade-off there. You could also do it all inside of a single file where you have the documentation piece at the top and then the implementation below it all in the same file. You could pull that off too. Somewhere in here, what we're really seeing is industry would say that the choice was we like to have one file with all the implementation in one place. That's what industry has said. Java doesn't support header files. C# doesn't support header files unless you're bringing in C++ libraries. They have a way of getting old libraries into it. But in general, the modern way of programming is when you create an object, you create it and implement it all in one place. So even though I'm sitting here and saying that, oh, you know, I think it's a good idea to have two files, industry does not agree with me. The way languages have moved is towards having one file. But then what they've done is a lot of the I don't think, does this guy have it? Yeah, it does. So one thing you can do is you can minimize inside the editors. You can kind of minimize your code. So anytime you have a function that does something, let me go to this file. So now the implementation file looks like it's relatively self-documenting because I've minimized the potentially hundreds of lines of code. That's my implementation portion. I've just minimized that so it's sucked up. So now I'm looking at what seems to be just a single line that tells me what this guy can do. And then if I'm really interested in the guts, I can expand it and see it. So maybe we've kind of solved that problem more on the editor side, the programming editor, than we did in what the language supports, because maybe less files is better when you have a very large project. Okay, but I'm gonna go ahead and just at least for this one, do it in two separate files if that's cool. All right. So what did I say for dice that we have? So we have a class dice, and then we're gonna have a public section. We haven't talked about public, private, protected, or anything yet, but that's fine. And then I said we're gonna what did I do? So one of the things we're gonna keep track of is the number of sides for our dice. All right, and then we're gonna have so that's, what are these guys called? What kind of animals, and as far as class naming conventions, are my variables called? Good. Fields. These guys are fields. All right. Next thing I'm going to write is a constructor. So I'm going to write my constructor. Constructors have to be named the same as the, let's see, we haven't talked about, we'll talk about that today. We'll have that guy taken into S. Actually, let's have it taken number of sides. All right. So notice the constructor must match the name of the class. And constructors do not have a return type. So they look a lot like methods. They look a whole lot like methods. But you have to have the name of the constructor be the same as the class name. And they will never have a return type because constructors are always used in conjunction with that new keyword we looked at last class. And the new keyword always goes and gets us memory. That's what it does. Okay. Therefore, the return type of this will always be a pointer, a memory address. So why make us write it if it's always going to be that way? All right. And then I want to have a single method for rolling, right? Int roll like that. Go ahead. This is just the header file portion. I haven't implemented it yet. Yeah. All right. So I would say historical standard C++ would do this. This would be you describing what your object will be able to do. And then in a separate file, so we'll do our dice.cpp. The top, we will include dice.hpp. And notice I have the double quotes around it. What do the double quotes mean up there? Huh? Yeah, it means I wrote it. Look in my directory for it. Don't look in the system stuff. Because otherwise we'd have the little angle dudes around it. And that makes it something that I didn't write. All right. So now in here, I want to go ahead and implement those pieces. So I'm going to write my dice constructor. Here, I'm going to steal this guy from here, just so I use the. All right. And this is me saying, I am implementing something that's part of the namespace for dice. That's how you connect the dots there. So a little bit of an inconvenient syntax, but this is how you glue the header file and the implementation file together, is by doing that. You include the header file here, and then whenever you're expanding on what was defined inside the header file, you do this little jazz there. All right. So in here, I'm going to say sides is equal to number of sides. And then I'm going to have my roll method. All right. And notice the return type comes before it. So dice owns this method called roll that I'm implementing, but its return type is int. And that comes outside of that little syntax. This is more just, hey, you got to learn the syntax for it. All right. And what am I going to do inside of here? Well, inside of here, I'm actually going to do my rolling of the number of sides. All right. Well, so now I got to say, well, how do I get random numbers? So I needed to do that srand thing. Remember? So let's see, what was that inside of a library?
Yeah, I think it's
I need time.h.
no, that's the other thing that you-
Oh, you need time?
No, I think I did either.
Oh, you didn't do time null, you just put null in there. Okay. Yeah, that's so what does srand do? What is that function's job? Good.
Doesn't it set,
Yeah. So when we deal with random numbers, a lot of times when we talk about kind of giving it a starting point, we seed the random number generator, and we want to seed it with something fairly random. So he mentioned that you can just pass it a null value. So I can just do, oh, so you can do time.
Yeah.
Why is it doing all of that?
Yeah, that works.
So you can do that without the time header? Okay, well, we'll give it a shot. Yeah, and we're still calling the same function, just some of the newer things are, since they're commonly used, they're pulled into the standard standard template library for C++. But we are seeding the random number generator with some random component. And typically when you're asking for time, it's going to give you, my guess is this is going to give us the current time to the millisecond. It might do something with what's called the epoch time, which is the number of seconds since 1970. But whatever, it's giving us something that if we were to run this program back to back to back to back to back, we're getting a varying number that we're seeding the random number generator with. So I'm going to seed it once like that. And so that's happening inside my constructor. So when I create this dice object, I'm going to go ahead and seed the random number generator. So this guy, this dice that I'm holding in my hand, he has randomness built into him. Okay. And when he was created, we seeded it with a value. So now when I roll him, he's going to get different numbers. And if I create 5 D6 dice, the idea is each one of them was seeded probably with a different value. So when I roll them, I'm going to get different values for each individual roll rather than getting the same values repeated. All right. So now I want to return a number between 1 and the number of sides. So I can return rand sides. So that's going to give me a number between what, 0 and sides minus 1. Oh, actually, rand, hold on. I don't want to use that version of the function. Rand is going to give me a number in the range of all integers, right? If I mod that by sides, now I'm going to get a number between 0 and sides minus 1. And then if I add 1 to that guy, now I'm going to get a number. I'm going to put some spacing in here just for readability. Now I'm going to get a number between 1 and sides. Okay. So that's what our roll function looks like. All right, so now I'll go back into main, and what did I say to do to test this? Create a 20-sided die, 10-sided, and a 4-sided, okay. So I'm gonna include dice HPP. All right, so I'm gonna go ahead and create some dice. So I'm gonna create a dice pointer D20 is equal to a new dice with 20 sides. Dice pointer D10 is equal to a new dice, what did I say, 10 sides? Dice pointer, what, D4? Equals new dice with 4 sides. And notice this is the reason why the constructors don't have a return type. When I look at my constructor here, this method had a return value, a return type event. My constructor does not have a return type. Why? Because it's always, this is my call to the constructor. It's always being called with a new keyword. And the new keyword is our real estate agent that goes and asks the operating system for some memory. So this stuff right here is always going to generate a memory address. Good. Why can't you use the ampersand? Oh, like this? That syntax is just not going to work. Construct object-oriented languages, they had to do something to upgrade the procedural language C to the object-oriented C++. And the way you create an object is through this new keyword they created. The new keyword was created with part of the object-oriented language. So it was part of the, I don't know, the 1-2 punch of creating an object. It's not, doesn't exist. Regular C would use malloc. Actually, old regular C would use alloc, ALLOC, to allocate memory. What we've used is malloc to allocate some number of bytes. The new keyword automatically says, I'll go and ask for enough memory to build you one of these guys. And he's figuring out the details of how much memory is required behind the scenes. All right, so now I'll do a C out, D20 roll. And I showed this syntax last time, right? With the arrow?
Yeah.
Okay.
What was the alternative syntax?
Well, here, I'll do it on the next line. C out, star, D10, dot roll. These two guys will accomplish, well, technically they accomplish the same thing right now. So D20 arrow roll says dereference the memory address D20, give me the value that lives there, and then call his roll method. Well, since this would be what you basically want to do every single time you use an object, they've given us a nice special syntax, this arrow syntax, for saying, when you use the arrow, I mean dereference this guy first and give me the value that's there, and then call one of his members, field, function. All right. So if you're more comfortable, if you always want to use the dot notation, you can do this. That would be pretty rare to see that. The arrow syntax was added at a later date. So when C++ first came out, you would have had to dereference all objects this way, which is going to get pretty tiresome pretty quickly. No, I don't think I have anything overly private in there.
I once had a class where like one of the professors got an email and it was like, this student has COVID, like every. No, no. No.
Yeah, it happens. Better than, like, you know, your subscription to some like
Some adult
private,
website,
some adult websites has been renewed, has been, or the credit card has been rejected.
Yeah.
All right, expecting a semicolon after something. Oh, this guy. When I create a class, you need a semicolon at the end of the class. Oh, it's the null. Did you use uppercase null?
Yeah,
Then you had to have included.
I think you use IOStream.
Oh, null lives inside of IOStream.
Yeah.
Yeah, so even if I brought in, even if I did bring in time, it would still not work. Is an IOStream?
Yeah.
I just want to try this real quick. I'm gonna bring in time.h. I just want to see if they've packed that with stuff. So time.h seems to know about null. That's pretty funny. SRAND, well, so SRAND is only an IO stream? That can't be right. Okay, yeah, so SRAND is inside of the standard C library. Yeah, it's using the Unix command. Nah, whatever. It's just IO stream like this. That's weird. So IO stream defines both null and all the random things, and then so it's like as they've been upgrading stuff to take things that are commonly used, like random number generators, and pulling them into, like, why would a random number generator be part of IO stream?
I think it was the first time I've seen this stuff.
Well, no, it just doesn't make any sense. I mean, from a language design perspective, I mean, it's like poorly organized. So like if you are working with a toolbox out in the garage, you're trying to organize screws, right? And you have screws of all sorts of different sizes, and you find a paper clip that's going in with the medium screws, just because, for no good reason. And now it makes no organizational sense.
It's somewhere instead of like its own separate thing, you have to like.
I don't know if it is. I think it'd be better to have it in its own separate thing
If I'm looking for a paper clip.
with the medium screws, right? Yeah, but he never found the paper clip because he's never going to look with the medium screws. I mean, IO stream is specifically for input output streams. So this should have stuff in it. If I go back to my terminal here. So I just can't see what's in IO stream from man files.
5 to 2.
All right, let's see if this guy gives me the list of stuff inside of IO stream. Oh, this will be interesting. It shows me C++ 98 and C++ 2011. Did it expand? It's mainly defined inside of the iStream header, so we gotta follow the yellow brick road. No. Okay, automatically includes iOS, Stream Buff, iStream, OStream, and iOS. Okay. Well, here's some nice things for converting between bases really nicely. Okay, so I didn't see it in there. Not in Stream Buffer. I think I just looked at iStream. There was nothing fancy in there.
Does it matter if it was a header?
No, I mean the header file is what defines what's in there. This is here's the features this guy has. So for instance, like the null value is a field. So it should define in there what that field is. Okay, so this has a whole bunch of template classes, so maybe null is in here, which would be bothersome. Okay, well, without spending more time, my feeling is it's undocumented. So more than likely what has happened is inside of the implementation of one of these things, it's included time.h. Or it's included the library that has null in it. So when it actually links these guys, when you compile, it's bringing in all the header files involved, including the ones that these guys used. And one of them had null sitting in there. So realistically, if I'm writing this, I would probably I would bringing in IOStream to get the null value. That's nonsensical. C++. Let's see where null is supposed to live. Oh, we could do that. All right. We could do that. I could do that. Okay, so time was not declared. So then I would do include time.h. But now I'm gonna lose srand. Yeah, what the heck? That's just stupid.
Well, time to use the drone.
I'm guessing there's like a random.h library. Is what it is, random.h. Rand.h. Yeah, but it doesn't make sense. So I mean, I get it that it works.
I don't understand why.
Let me just look up S rand.
Firstly, this is reflected to you know.
Where's it? Oh, CST_dlib. But that's probably in its own namespace too. Perfect. There we go. All right. This would be the correct way of writing it. I understand that it worked otherwise, but my guess is if we spent some time and we found the source code for IOStream and peeled it back, somewhere inside there, they are including this and including this, maybe for completely unrelated reasons, but that's what gave us access to those guys. So the correct thing for us to do here, and actually, since I have the standard library here, my guess is null is defined inside there. Okay. So, but we already just saw that null is actually just a funny way of saying zero. It's nothingness. All right. This would be the more correct way of writing it, even though the other way worked. Because, hey, I'm using time here. Where does time live? Oh, you found that in the toolbox with the bucket labeled time. Okay. And I want to use this value null. Well, where did that live? Well, it was in the toolbox inside of that bucket where I put, I don't know, default values or something like that. So C standard library. So this is actually bringing in an old, not even C++'s library. This is bringing in C's standard library.
So now we can explain what's happening.
That's it. Yeah. I don't like situations where we say, oh, this is okay because it worked. I'm not taking off points if you did that, but from a good programming practice should be that just because something works, if you don't understand why it works, you don't just accept that. Because in chasing the why it works thing, it might explain something else you run into later on, when you might just say, oh, well, I'll just use IOStream and that's worked before. It's a duct tape. It's a duct tape solution, right? But if you don't want this weirdness, the C standard lib thing, you could just do that. Time 0 means the same thing. And that gets you your random, your seed value. Go ahead.
Class isn't necessary. Object, but like every class, but did you say that you kind of said that a class isn't object, but I get the impression that
No, I mentioned last time I called it a blueprint. If you remember. So here's my class. A class is the blueprint that teaches me how to build dice objects. Over here in main, D20 is an instance of the dice object. D10 is an instance of the dice object. D4 is an instance of the dice object. So these are variables built using the constructor, using those blueprints. Yeah, the value they hold is a pointer to a dice class. But we would call this guy, we would say, if we were to describe what kind of animal that is, yes, it's a pointer to a dice, but we would say this guy represents an instance of the dice class, the thing that lives at the pointer. So really, to be completely accurate, we would say star D20, the thing that lives at that memory address, that's the actual instance.
Yeah.
Star D10 is the actual instance. Star D4 is the actual instance. Yeah. So D20 is a variable that holds a memory address. Star D20 is the actual instance of the dice class. Okay. Yeah. Well, using the word object, I guess, means some different things there. I would generally say, if we say that this is an object, if we want to say this is an object, this would be an instance of the iPhone blueprint. Somebody used the iPhone blueprint and built this guy, and somebody else in here probably has an iPhone, same vintage or whatever, and they have another instance built with the exact same blueprint, but these are two physically different objects. Okay. And this is no different than like going into a housing project where all the houses look the same. Single blueprint, they built 30 houses. All those houses are identical in every way, except they are physically separate houses. Each one of those is an instance of that house blueprint. All right, so questions about this guy. All right, so now we have the ability to create a dice object and roll the dice, and this looks a lot cleaner than when we wrote something very similar to this without using classes before. Sure, a lot of the logic still exists, but when you look at main, we don't have a whole bunch of methods or functions written, later on. We don't have them prototyped at the top. When we look at main, all programs begin and end with main. Main now tells us a story. What do? Well, we're going to go to the store and we're going to buy a D20. We're going to buy a D10. We're going to buy a D4. Except we like homemade. So we made those in our basement. All right. 3D printed them or something like that. With our teeth. All right. So, we created one way or another a D20, a D10, and a D4 using the materials we had around, which we had also invented. And then we use them, we proof of concept, we prove that we can use them right here. Okay, but the details of what a D20 is, or what a dice is, were hidden. Well, they were described here in the header file. That what's a dice? A dice is a number of sides, and it has the ability to roll. That's what a dice object can do. And if we want to see how it accomplished that, we can go into the CPP file of this and we can see, well, what happens when a dice object is first born? If we're interested in the things that go down during that, right? We set the number of sides and then we seed the random number generator. And then what happens when a dice object is rolled? Well, we generate a random number, which we know gives us a random number in the range of all integers. Have we looked? Does it give you negative values too, or just 0 to 2.1 billion? I don't remember. I know we tested it. Just positive numbers? Okay. I know in Java, if you use their random number generator, it gives you in the range of all integers. So negative 2.1 billion to positive 2.1 billion. But whatever, this gives us, he's saying it gives us a number in the range of positive integers. So either 0 to 2.1 billion, or if it's specifically positive, it's possible it'll give us 0 to 4.2 billion using the entire integer space, since we don't need to store negative numbers. But in any case, this gives us big random integer, and then we're modding it by the number of sides we have that we're working with. And that guy is then giving us a value between 0 and sides minus 1. Because that's what remainders will be. You have a remainder of 0 up to the value you're dividing by minus 1. Because if the value you're dividing by was a remainder, then it actually went in an additional time. But we actually want a value between 1 and the number of sides, so we just add 1 to that answer. So this is the implementation of how those dice actually work. Most of the time, if you're using somebody else's library, like we did here, we're using the time library. We don't know, well, at the very least, we know that this function lives in there, right? The time function, but we don't know how it's implemented. But we don't care. We just know that, hey, this guy gives us a time. And if I pass it a 0, it gives me a random, or it gives me the current time without any adjustment. I'm guessing for the current time zone, but this also, like I said, might give me something called epoch time, which is just the time since 1970, usually in milliseconds. Go ahead.
When I was playing around with this yesterday, I put S random method down at the bottom, and everything worked fine, but on the thing when I called the random function, it would give me like, say like that right there was a 2, 2, 3. It would give me the same number. So like I would go roll again, maybe just random.
Okay, yeah, let's just do it. It actually surprised me it would give you the same numbers.
It wasn't all the same, but like it was like more often than that. And then when I switched over to
Yeah.
main, that would give more.
Yeah, and I'm going to explain why here in a second. Let me just run it real quick. What'd you do? I think it was just a hiccup. Best friend was not.
That's what you do, that. Then you put it in.
Oh yeah, you put it in the library, the BIOS stream.
Oh, it came from IOStream.
Yeah, and then we included the other library.
No, that was for null.
Yeah, so we used that one other library with that. Main.
Oh, that was for null. I don't have it in main.
Or main you use.
IOStream's in main. Now we have a new mystery. Okay, good. So what have I changed since the last time I ran it?
Got rid of the CSC200.
Really? I thought I ran it after that.
Or is that in the header file?
Hmm. Header file doesn't have anything in it because we're not using anything special in here. Eventually we will, because eventually we might have pointers to other classes. So we'll need to include the headers for those. And then we'll also have to talk about, well, what if you have a circular include? This header requires this header and this guy requires this header. So now they're requiring each other. So what you got to do is something called a directive called if and define, if not defined, do this. So then it asks the questions, kind of like an if statement built up there. This RAM was not declared in the scope. This is what I had that ran a second ago. And we've looked up that but didn't I run it after that? Or did I really not? Well, I know I deleted it, but I thought I ran it again right after that. Clearly not. But it does live in IO stream, which is why it's worked in the past. So actually, even in class before, we've misused this. We took advantage of the fact that it was coming out of IO stream. When I probably made the assumption that, oh, random number generators are things that we use pretty often, so it must just be part of the standard library. But it's not. If it was part of the standard library, it would have worked right here. So it's part of the C standard library, but not part of the C++ standard library. Which probably means C++ probably has a more updated and we can explore this a little bit because I'm not giving you homework over Thanksgiving. So well, I'm giving him homework specifically.
Maybe a memorable professor, he just puts you random.
We're talking about random number generators. And we forgot to seed it. He's coming up every single time. He goes,
Random, and it's just him.
he goes and complains to the dean. Dean's like, yeah, that sounds like Lippman. Like, get out of here, you're wasting my time. Sounds like Lippman. He's crazy, but you'll probably get a better grade than you probably deserved. Just move on with life. Let's see if there's there's got to be a more up-to-date random. Well, he's using the old C library. There has to be a C++ version of, yeah, include random. So this is giving a random range. So let's do C++. Well, it's not a friendly library at all.
Question about looking stuff up. Why people like to use like the STD and not use like the namespace for it? Just, like,
Oh, you mean like when they're doing like a C out? Yeah, I have no idea. What he's asking is, where can I show it? Show it. Well, I can do it in main here. So if I leave this line out, now all of a sudden you have to say STD like that to call C out.
My assumption is that's just how they learn it.
Yeah, but that's, I mean, that again, that would be pretty inconvenient pretty quickly, right?
Well, I've heard explanations. I don't think they're good explanations, but they're like, they say that when you're writing big projects, you might have to like create functions that fit with that library. I don't think.
That actually, that's not a bad.
I-
Well, but let's explain that a little bit. So what he's saying is by me bringing in this namespace standard, effectively what I'm doing is I'm saying, give me access to everything that's contained inside of that namespace standard. Now, in this case, I'm only using one thing from that called cout. Now, if I'm a programmer and I'm writing some of my own stuff, okay, I'm writing some of my own music in here, there's a chance, since namespace standard might have, let's call it 100 things in there, and I'm only using one of them, I might happen to create my own thing that has a name conflict with something that exists inside of namespace standard. Because there's probably a bunch of like common things in there that just might have names that conflict with the name I'm using. So now all of a sudden in my local namespace, something I wrote, it's saying, you know, this has already been used because you're using namespace standard. You're bringing that whole thing in. So this is letting you be targeted and say, look, I don't want you to give me direct access to all of it. I want you to just, you know, look, you can, the cout I'm talking about here, you can find inside of standard. That's where I want you to get. I want you to get that dude's version of cout. Make sense? So realistically, it probably is a pretty reasonable argument for large projects. But I would even, but I would flip it, and I would give a reason why that might be a bad thing, though, to avoid using namespace standard, because now what you've done is, by using namespace standard here, we're creating code that self-polices. It'll yell at us if we have something that we've named something that conflicts with something in the namespace. So we can just, the easy solution, we just change the name of our thing a little bit, right? Okay. But if we don't do that, and we have something that's named something, and then all of a sudden later on we do something else that doesn't conflict, but later does conflict, we might have code that now is kind of error prone whenever you make a little change to it. There's a thing that we'll talk about probably in the next course called regression testing. So when you write software and you test it initially, those are usually called unit tests. You make sure that, you know, here's the 50 things that my software needs to work for, and you test all 50 things and it gives you a big thumbs up, everything's good. Well, then when you add a feature to your software or to do something else, a 51st thing, right? You want to make sure it still works for the first 50, that you didn't break something there. So regression testing is going back and make sure it works for everything it used to work for, and then also works for the new thing. So I would say that in programming like we do in class, we typically don't do a lot of formal unit testing. We do spot checks, right? It's like, let me just test this in a couple inputs. We've tested on everything. It works perfectly all the time. It's great. All right. But in industry, you probably want to spend that time writing. I mean, unit tests are something that are things that are built into modern languages that allow you to create these special functions, unit test functions, where you can, after you've made changes to your program, you can test your code against those unit tests by just using a single command. Run all unit tests and tell me which ones it passed. So the idea is you kind of have a built-in spot check when you make a change to make sure you didn't break something else. And you're always testing it with the same stuff, and you don't forget, like, oh, there was this one very weird bug that I fixed 2.5 years ago, and I tactically didn't put a unit test in for that because it's never going to happen again. But now you never tested for that weird bug again, and maybe you've reintroduced it, or somebody else from your team who wasn't part of the bug debugging thing before has now reintroduced it. Something like that. Yeah. So it's which is kind of why so I mean, really, these are all, I mean, that was a really good point. Today's discussion is actually a really good discussion, because it does come down to what's the right way of doing things, even though other things might work. Just because something works doesn't mean it's the right thing, and there is value in us understanding why it works a certain way. And unfortunately, in an older language like C++ that is less formally documented, sometimes you have to do some chasing. But I promise you, if you're using a more modern language, Java, C#, getting to the bottom of this first of all, this stuff doesn't pop up very often. We don't put paper clips in with the medium screws, and it didn't make sense before. Now we maybe are a little bit more proactive about that. That doesn't mean that in a modern language, weird stuff doesn't still pop up. But we have a very formal documentation for our more formal languages, where we're not necessarily getting documentation from 5 or 6 different websites. You go, if you want Java documentation, you go to java.sun.com or Oracle's website, and you go to the official documentation for the language, which is very well documented, easy to navigate. It's probably the biggest strength of Java, in my view, is how strong their documentation is.
You can know why.
Yeah, and you don't, it's not a Google search. It's I mean, you might just do a Google search real quick to get you to the right class, and rather than having to click 6 times through the documentation to get down to the right place. But it's I'll just show this to you real quick just so you see it. So if I go to so I always go to java.sun.com. But I've been doing this for a few minutes. So the company that invented Java was called Sun Microsystems. They are no longer a company, but it will take you to Oracle. So, and then I go to, oh, they've changed their site because it used to be over here on the right. Ah, that would have. This guy will get me somewhere close. This gives me this is standard edition 7. I think the newest version is what, 9 or 10. Yeah, here's 9. All right, whatever. Actually, it'll be cleaner for me to show this to you. So if I show this to you here, if I click all classes, this is literally every single object that exists in the Java language. Now, realistically, though, if I want to do stuff, what's built into the core Java language when I don't import anything? That's what's in java.lang. That's a much smaller list of stuff. Things that are in there like strings. We have types for all of our primitive types. We have Booleans, we have bytes, we have characters, doubles, floats. So we have objects for dealing with those. But if I were to go into, for instance, the string class, and I usually advertise that Java is a string-based language. So strings in Java are very powerful. So just like we're talking about creating objects here, here are the fields that are part of strings. Here are the various constructors for strings. Notice they're all named string, but we have different ways we can create strings. And then here's the methods that strings support. So we have a whole bunch of methods that strings know how to work with, or that features that strings give you. So we can trim the white space off the end of a string. We can convert a string to uppercase. We can convert it to lowercase. We can get a character array out of it. We can get a substring from a starting point, or a starting point and an ending point. We can split a string based on a regular expression. We can replace an old character with a new character, yada, yada, yada. So all sorts of things, but the documentation is all here in one place. We don't have to do some Google search to go and find out what this guy can do. And to the point of why in modern languages like Java, we don't have header files, it's because the documentation, this uses a technology that Java came with from day one called JavaDoc. And you can use JavaDoc to generate your own documentation in this format from your code, as long as you put the right little things into your code, like little special lines to let JavaDoc know what to put in what category. But you can go and you can find out how these things work pretty easily. If I want to know how concat works here, I can just click on this guy and it gives me a whole little description of what the guy does and gives me an example how to use it, all that stuff. And this is the official documentation, you know, not some Reddit thread or something like that that you're using to debug your code.
Some guy Stack Overflow.
Which is still good. I mean, I'm not complaining, because you can get a lot of knowledge out of messing with that stuff, and that's just what you have when you're dealing with older languages. But maybe we can make the argument that to defend Java for removing the idea of header files is okay, because the documentation for it is so specific here, and they've given you a tool, JavaDoc, to effectively generate your own documentation. Right, but they've also, Java comes with a tool so that when we wrote our dice class, for example, if we chose, which most programmers don't, but if we chose to use the couple of declaratives for that JavaDoc's expecting, we can then just run JavaDoc on our folder and it will generate documentation that is in this format for us. So we can create our own header files after the fact by just having web-based browsable documentation for our whole project. If we decided to take a little bit of extra time in writing that, which most programmers don't. Java's kind of famous for that, giving some functions that if used often would be amazing, but rarely are actually used that often. That's kind of a thing. All right. All right, so in any case, this is the explanation for a lot of these things. So let me at least introduce a topic here just in our last couple minutes, just so it's kind of in your head. We talked about the new keyword here, instance. Man, I just have my slides all over the place here, don't I? Man, this must be impossible to read. Man. I need a little randomizer button up here. I'm not sure it would be noticeable. I'm not sure it'd be that different. Yeah. How many how many times do you have to shuffle a deck of cards before it returns to its original state?
You would have to understand.
Like, what if one card is off?
Oh, we're gonna write a program that does that. I'm not kidding. It was not hard. You know, we're going to be writing a card class with, it's going to have a suit, a value, things like that. Okay, but I want to introduce a keyword, this keyword. And this, one of the funny things with the this keyword, it's hard to teach the this keyword without saying the word this a whole bunch of times. Sometimes I mean the this keyword, sometimes I mean this. Okay, so this is how an object refers to itself from within itself. All right, and we're going to see examples of this, but whenever you say I or me in real life, like I went to the zoo, I'm talking about myself in terms of myself. So this keyword is equivalent to us saying I or me or mine. All right. Other languages self is Python, Objective-C. Me is Visual Basic. So those are all synonyms. This, self, me. Self is the one that's most common, that is the most common competitor with this. But this keyword is probably still the most common one. So when we come back next week, we're going to look at how we can clean up. So I'm going to say start here. How we can improve our naming conventions and stuff using this keyword and getting used to using it all the time, even when it's not required. All right, questions, comments, concerns, bribes. Oh, one last thing. I put it up on Slack and I might have sent an email about it too. Next Monday night, it's going to be across the hall on S118B, the same place we had the crypto metaverse talk the other day. We're going to have about an hour presentation on quantum computing. It's not required. I'm not going to have a homework assignment associated with it, but I strongly, strongly, strongly encourage you to stop in and learn about it. Quantum is freaky deaky. And if you want to make yourself interested in it ahead of time, do a YouTube search on something called the double slit experiment, and you'll stop sleeping at night. and then come in and learn about how we're going to start programming using quantum mechanics for our core. Double slit experiment. Pick one of them as like a cartoony looking one.
Okay.
It's kind of almost like evidence of God. It's freaky deaky stuff.
I know someone this on Zoom or anything like that. I've practiced it. I don't know if it was
Yeah.
out of it.
Well, and the answer is yes, we'll try to, but he specifically requested to use the whiteboard. So I don't know I don't know how well that would translate. At the very least, we can put it on Zoom and you'll see what you can see, but you can at least hear what it is and we'll record it. So I just don't know if you'll get the full effect, but I get it. So, but it's regardless, go and look up that video. It's double slit experiment. All right. Yep. Let me stop the recording just so I don't forget.